Welcome back, everybody. Great to be here with Professor Dean Mobbs from Caltech. Thank you for coming.
No problem. Thank you for inviting me.
Yeah, we're gonna get to know you a bit more, and we'll come to this question that we love in this podcast around intelligence. But why don't we get there via your story? And let's start with you, your childhood, and the big experiences that took you to this point in time now.
It's a long story, but I can shorten it, and I'm hoping you'll find it interesting because it's not conventional. So, grew up in England in the 70s and 80s, and I grew up in what we call a council estate, which is like a government housing. So I didn't know anyone who had gone to college or anything like that. So I grew up there, and I left school, dropped out of mainstream education at 13, left school at 15, and painted houses for years. And then I was amateur boxer, and I wanted to go pro, but I was working as a painter and decorator, painting houses, and I was working in London, and I couldn't get back to the gym in time, so I'm like, well, I really want to become a professional boxer, yeah? So I decided to quit my job and go in the army, which I didn't end up doing. I nearly went. I took all the tests and everything. And then I thought, well, you know what? I'm going to go back to college and get an education, because when I went to the army, they said you can't get any education there. They don't do that in the UK. You usually get your education and then you go into the army. But I know in America it's different. So I went back and then quickly discovered, after leaving school with nothing, no qualifications whatsoever, that I was actually a better academic than I was a boxer. And that was quick, because I remember the first essay I wrote in English, I got an F. And I'm 21 years old at this point, yeah. And they showed me how to correct it and everything. Got straight A's after that. Just had to be shown once. And that showed how much little attention I paid at school. So then I went, did my A-levels and went to University of Birmingham, where I did a degree in psychology. That's where I met my wife, who was an exchange student, Cindy Hagen from UCLA. So then she dragged me back to California after we finished undergraduate, and we got married. And then I was waiting for my green card and everything, but then I got a job as a research assistant at Stanford, working in brain imaging, in psychiatry, working with Alan Rees. So I worked there for 4 years, and that's where I learned how to do most of my science, to design experiments, write papers, and so on. And ended up being quite successful there as a research assistant, because I published quite a lot of papers, and I got offered a PhD at University College London, where I worked in one of the best imaging departments in the world with Chris Frith and Ray Dolan, who were my supervisors. And that went really well, published in good journals, and then moved on to a postdoc at Cambridge, where everything went well again, research-wise. We can talk about the details of what that was later, but and then I was offered a assistant professor position at Columbia University. So I was at Columbia University in New York for 4 years before I was offered the position at Caltech, where I'm doing the research now, where I focus mainly upon brain imaging, computational neuroscience, studying emotion, particularly fear and anxiety, as well as social behavior.
Wow. So an impressive CV. You've done the tour of top universities and built up all of these degrees. And it seems like you're the ideal person to talk about intelligence. But before we get there, could you just tell us in layman's terms what brain imaging is? Because I know that there are different ways of doing it. What is it you're trying to achieve through brain imaging, and what is it?
So brain imaging, there's a number of different techniques used. The one technique that we focus on is called functional magnetic resonance imaging. And with that technique, what you're looking at is blood oxygenation changes in the brain. So what happens is when you think, let's imagine I'll show you a picture of a face. Yeah, the simplest way to explain it. And there's a region back here in your brain called the fusiform gyrus, which we know it processes faces. Yeah. So if I show you a picture of a face in the MRI scanner, what's going to happen is the neurons in that region of the fusiform are going to suck up all of that oxygenated blood, which is iron rich. Yeah. And when it takes all the oxygen out of the blood, but it has to be replaced, yeah, because if it's not replaced with fresh oxygenated blood, you'll have a stroke, yeah. That's just the way that the brain works. So what happens is you get this exchange between deoxygenated and oxygenated blood in the brain, which is a proxy for neuronal activity. Yeah. So when you see that face compared to control condition, that region will light up with the oxygenated changes in blood in the brain, and that's when you see those bright blobs that you see on the MRI scans that you see in a lot of the publications and so on. So you look at changes in the sort of magnetic properties of that blood, yeah, because oxygenated iron are not oxygenated yet.
And is it fair to okay, wow, so that's technical. And
yeah.
Is it fair to say that we're looking at correlations, but not necessarily causation?
It's correlation, because what you're doing is you're looking at how those properties of that neural activity are changing as a function of how it correlates with the change. Because you present the stimuli multiple times, you just don't present it once. Because to have enough power for the statistical analysis, you need a lot of trials, yeah? So you run that, and then you're looking to see what those brain regions are. They become more active the more you present that stimuli, yeah? So it's a correlation. Now, what you can do is use more causal techniques like brain stimulation. You've heard of TMS. It's used in therapy a lot. You can go in, you can stimulate those regions and knock out those regions and show a decrease in neural activity, and then show how that changes people's, say, perception of a face, for example. So you can use other techniques to do that. But you are certainly looking at correlations in the brain. But they're very, very consistent across groups. I won't say individuals, because the way that the statistics work is you need a lot of people as well. You need a lot of participants, volunteers to do those experiments. The signal on individual is kind of not so good. So you need to kind of look at groups. But certainly correlational, but there's certainly causal techniques that you can use as well to understand the mechanisms behind that.
So that you're looking at and you're using the exchange of new blood with and the fMRI, the functional magnetic resonance imaging is picking up is it proper to say it's picking up iron transfer?
The iron, yeah, because the magnetic properties of the deoxygenated and oxygenated blood are different, and that's where the MRI comes into it. Yeah.
And so, I guess the next step from facial recognition by one dedicated portion of the brain to the work that you're doing involves detecting or making sense of exchange of affect or emotion.
Yeah.
How would you fit that into the interpretation you just gave about facial recognition?
Yeah, so that's just as simple as looking at the visual areas of the brain, association areas of the brain. We're interested in a number of regions in the brain that are involved in emotion. Many of you have heard of the amygdala. It's probably the most famous region, but there's more than that.
Yeah.
And the reason is because it's a region that's easy to study. And we have very good models about how to activate that region in rodents, in monkeys, in humans, using different techniques. And lesion studies, we have patients who have genetic abnormalities in that region and can't process fear. Yeah. So it's very well known because it's very well studied. But what we're interested in is how fear transfers through the brain. And we use proximity for that. So I'll give you the simplest example of what we've done. We've done many of these different studies, but what we've done is, for example, put people in the MRI scanner, and we put their foot in a box, and then we move a tarantula closer or further away from their foot, or we make them believe that we're moving a tarantula.
Did your IRB approve this?
Yes. In England, yeah. So the point is that the original work that I had done as a PhD student, looking at when like a virtual threat comes closer or further away, we want to use a real threat. And what you find is that when the threat's distant, it activates part of your prefrontal cortex and a specific part of your amygdala called the basolateral amygdala,
Right.
which we know are highly connected to the subgenual and other. I'm not going to go too technically into that. But when the threat comes closer, you switch to a region where there's no region in the brain that's a fear region, but if there was, it would be this region, which is known as the paracaudal gray, which is this. You see it's across species, even in fish. It's very ancient. And there's columns in this region in your midbrain that if you stimulate specific columns, you'll get fight, flight, and freezing behavior. I'm not going to go into too much more detail than that. But what happens then is that I can take this threat, let's imagine this cup's a threat. It's still the same threat. It still gives you an electric shock, or it's a spider, But the brain areas that when it's ear to ear are different. Yeah. So that's what the work that we've done over the years to show that how do you switch between these systems. Now, when the threat's distant, it's a model for anxiety, because anxiety is about the future, whereas fear is about now, reacting to what's happening. So this is our model of being able to look at fear versus anxiety in the brain, depending upon the distance to where the threat is. And then we also have done work looking at how you switch between those systems, how you implement safety into them, and how it changes that system, and so on, and done other work as well. But
I can see this having pretty profound implications for the way that we live. The difference between anxiety and fear, something being far away and close.
It is. Well, anxiety is all about the future, and I think it's written a few theoretical papers about this, and one thing I think that's different about humans, this actually may come back to intelligence, in some respects, in a weird way, is that humans do two things very much different from any other species. They live in their imagination. They live in the future. And we learn, other animals do this, but we also learn vicariously through others, through storytelling, okay? These are two of the best survival strategies that you can have, because if I can imagine a threat in the future, I can avoid it. If I can learn from you about a threat, I can avoid it. Problem is, it makes us a very anxious species, If you're being fed all of this information via social media about threats all around the world, your anxiety is increasing, although it's not really built for that. That's why the internet's probably not such a great thing to learn about danger.
A pile up of fears,
Yeah. And I think also, I think that's actually a really good point that you just say there, is that I think as we get older, maybe our fears and anxieties do increase a little bit because we build this model of what can go wrong in the world. And as you learn more and more about all these things can go wrong, the world becomes a more scary place. So it's a very adaptive, because we know this with our kids, when you have your kids and you say, don't do that, don't walk on that wall, you might fall off, or don't run with scissors or whatever, You apply all of those bad things that can happen, to that model of trying to train your kid and say, don't do that because this can happen or this can. So you have to be careful about not making your child too anxious as well.
Is the scientific understanding you have of fear and anxiety, is that something that's helped you navigate those in your own life?
They always say research is me search.
Research is me search,
And
wait a second. I've been at this for a long time. I've never heard that, and that hits home.
People try and study the things that they feel that they're inadequate at. But I try and think about things as being the subjective emotional component to it versus the statistics of it. And the classic example is if you take a flight. People are scared of flying, but they're more likely to die on the way to the airport in the car, Statistically, if you were, like Captain Spock, you'd be very logical and think you would be scared of driving to the airport versus the flying bit, but most of us are the opposite way around, because we live with these, we don't live in a world of probabilities, well, we live in a world of probabilities, but we don't think in a world of probabilities.
Exactly.
We think in a world of emotion, and that impacts the way that we think about these things as well.
And our exposure to the world is mediated by media, whether it's newspapers or on the screens.
Yeah.
And and those media are monetized by appealing to fear and anxiety, which adds to the pileup. The quantity and the severity of it is monetized, and that's what you consume.
It is, and it works, and sadly it does. And I think the way I think about it is I like to strip everything all the way down to those basic physics of the world, which is those spatial temporal properties. What's the information that your brain's getting? It's making predictions about the world, but also it's getting sensory information, proximity and movement in the world, and it's taking that information, and then it's making a theory from that information. So for me, it's important to really start at the lowest level to understand these very basic features of what elicits these switches between these cortical and midbrain regions. I was just talking to a friend of mine, a filmmaker who's here at LILA, and talking about one of the classic examples is looming. If you have a sound which is looming that increases in pitch, it gives you it's sort of analogous to something's getting closer. That activates your amygdala like this, It just increases linear with the increase in feeling something's become more proximal. And the example about this, going back to the filmmaking, is Jaws, the Jaws theme. You don't see the threat. You've got that its own two elements of anxiety. The first is uncertainty. You don't know where it is. Secondly, you know it's coming towards you, and you're activating those regions. That's why the Jaws theme is just, it makes that movie completely. But it's just one example of building from those basic building blocks all the way up. Now we're doing work on social media, how you can elicit these threat states on social interactions during, in our case, argumentation.
Wow.
We're going to need a bigger boat. Isn't that the quote from Jaws?
It is,
Boxing. Painting.
How
do you think those have helped you in your academic career?
It's interesting. I've not thought too much about that, but I'll certainly say that when you come from a school where nobody goes to college, I often think that if you go to a very good school, the people who are good artists would go and become painters and go on to art school. The kids who grow up in the poor schools go and become painting decorators. They paint houses, So maybe I feel that there's always been some creative side to me, and that's the best. When I left school at 15, that was the only way I felt like I could express myself in some way, that was creative. But it wasn't until I got a little bit older and you get wiser and that you start to realize you could have made better decisions. So that's sort of one side of it. And the boxing is, I'll give you the example when you're boxing. I mean, what will happen is that you're going down the gym and then it's okay, you might be having a fight on Friday night. We don't know, because what happens is you're going to drive to this remote place somewhere that you've never been in England, and we're going to try and match you up with someone. You don't know who that person is, So you get in there, and it's just persons across the ring. You're like, are they good or not? Is this the next Sugar Ray Leonard, or Muhammad Ali?
Am I going to be one of his statistics?
But you have to have this
flexibility,
delusion that you're good. And you get out there and then you realize, this is going to be a tough fight. And then there's, I've got this. There is an element of uncertainty in there. So the only way I can think about it, how it's helped my career, is that we have to go and give talks, a lot of talks. That's what we do in academia, and I kind of just think when I would get nervous, because I think actually giving an academic talk, like the first time you give one, was much more nervous than fighting. Because there's so much uncertainty in it, and you just don't know if the things that you got in your head are going to come out of your mouth properly. So I felt that prepared me a little bit for that, not to be as anxious, and I think one way I would, just to finish on that, I've become very comfortable with feeling uncomfortable.
Well, could you just walk through very, very briefly There was a period when you were a fighter,
Yeah.
and you had no idea that you would have a distinguished career at one of the most respected institutions in the world. And then there was a time when you were in academia, but there was that uncertain time, uncomfortable time in between of increasing self-awareness and saying goodbye to something that you were committed to, saying hello to something that you were going into. Can you just reflect very briefly on sort of the emotional and mental space that you were in as you made that transition?
Complete delusional optimism.
That works.
And I think that I always felt that if I kept working at it, it would happen. I don't apply that to everything, but I just felt that it would come. And it came from the feedback here, because I worked really hard and I got some papers into some very good journals, some of the top journals in our field, and I could compare myself to other people out there and seeing that I was doing as good as them. I wasn't as clean cut. I come from a working class background and I don't have a distinguished accent or anything. But and that can matter sometimes, to be fair. And it does play to that imposter effect a little bit. I mean, that also occurs.
Sure.
I saw something funny about the imposter effect where somebody said, like, a lot of academics feel the imposter syndrome, yeah.
With reason, but go ahead.
Yeah, but then
Sorry.
then they say, but then this person said, but actually, it's correct. You should feel like an imposter because you.
Right.
That was a joke. It was a joke, but it's true that everybody feels it. But some people feel it more than others, and some people actually probably shouldn't be in the position they're in. Maybe I'm one of them, but it was a delusional optimism, and my wife will tell you this, but. I kind of felt like I've always felt like if I tick this box and this box and this box, that door will open. Yeah. And I felt like I was doing that. It's tricky when you go up for tenure. I'd put this, I was talking about this the other day, I had this expectation with the tenure that I would, that I needed to tick all of these boxes. And actually I look back, I pretty much had, but in my mind, I was very anxious when I was going up for tenure because I'd heard stories about people who had ticked all the boxes and hadn't got it. It's a bit of uncertainty there. But when I went up, I felt anxious because I felt like I quite hadn't ticked all the boxes that I wanted to tick. But I look back now, I had. So that was a situation where I kind of felt this anxiety. Right. But apart from that, yeah, it's. I understand what my limitations are and what I'm good at and what I'm not good at, and I try and focus on the things I'm good at and collaborate with the things that I'm not so good at. So that's the great thing about academia; it's collaborative.
And you were coming up through the ranks and then going for tenure at a very exciting time globally for the field.
Yeah.
Imaging had become such.
Yeah.
An exciting area, and it captured a lot of public attention. There are different media.
I think it was on a wave. I think the wave's going down now. I think when I first got into it, it was amazing how you had all of these psychological experiments, and we had reaction time and accuracy, how people said they felt within it, but we didn't know what happened in the brain. And all of a sudden, you took these experiments.
You're doing proxies of what's going on in the brain.
Yeah, and all of a sudden, this happens in the brain, and this happens to this experiment, or, what happens going back to intelligence when people score IO on intelligence tests, what's different about their brains? Why are they more intelligent? All these sorts of questions. It was this just amazing time. But now a lot of those questions have been answered. And going back to exactly what you said in the beginning, is it correlation or causal? Now we want to start getting into the mechanisms.
What is intelligence? What is your definition of intelligence?
Well, there's two ways to think about it. I think about it in terms of the research I do, which is probably, we don't want to go into too much detail about that now, but is what we call survival intelligence. How does an organism survive? And what decisions does it make? The classic example, which I don't know if I've seen such a to a few people, Stephen Hawkins and Piaget, was the ability of the organism to adapt to its environment is the classic example. When we think about it in terms of human intelligence, we can then begin to think about a different level, a higher order level of intelligence, not just this basic survival intelligence. or adapting more about what's the difference between somebody who scores high on an IQ test and somebody who scores lower. So the way I think about intelligence generally, in terms of if you're talking about high, like on the one end of the spectrum of the distribution, you're thinking about how people can just generalize across and pretty much any academic problem in the world, yeah, versus people who have specific skill sets. So you think about it like that. But yeah, I mean, there's many. The way I think about it is just simply adapting to the environment, but then it's much deeper than that when you start getting into the theoretical side of these things.
So it's adaptability, and then up to transfer.
Yeah,
Transfer of knowledge and skills, maybe across different areas.
yeah, yeah.
And are we doing enough in our schools to nurture that type of intelligence?
So this is a good question. So we know, coming from an education background, we know that there's the theories that come from the psychology, Spearman. So we think about Spearman and we think about fluid and crystallized intelligence. Crystallized intelligence is the buildup of knowledge. Yeah. So as you get older, your crystallized intelligence increases. Yeah, that's one side of it. Hopefully. And then the other side is fluid intelligence. And that's how you problem solve, think in the moment. And that actually increases up until about 25, 30, and then begins to deteriorate after that. Yeah. Yeah.
I knew something was happening.
Yeah. So that's the question, is in terms of relating to sort of education. A lot of the time in education, and I don't think these two things are separate, but in education, you're building up knowledge in the child, and as they build up that knowledge, just becoming more knowledgeable about the world. But are they learning to think? Are they learning to engage their fluid intelligence? That's one side of it. And then you guys probably know a lot more than me about the research from education, which is the multiple intelligence theory by Howard Gardner, and he has his 8 different levels of theory, which is linguistic, intrapersonal, thinking about the self, interpersonal, how you interact with others. These are all different types of intelligence. Yeah, I'm not going to go through all of them.
He even took it up to 11.
He went he's gone to 11?
Yeah, he's got a naturalistic, existential. Anyway.
Yeah. So
it's contested.
Yeah. And don't get me wrong, they're important. There's no doubt about that. But the one model I like, and this comes back to your question again, as you see, is Sternberg's model. And Sternberg talks about 3 levels of intelligence. He talks about analytical, that's sort of problem solving, and then he talks about practical, how you apply that knowledge to impact the world, maybe like an engineer, something like that. But the third one is creativity, and creativity is something that I believe can be trained in people. There's certainly individual variation in it in terms of creativity. There's no doubt about that. But I think that's something that not just feeding kids information, but making them think about it in multiple different ways and thinking creatively about it is an important part of I think of education as well.
Sternberg is was a great scientist.
Yeah.
I think there's a craving in society pretty generally for the lessons or the findings of theorists like you and observers like you to translate into making education better. I know there have been a number of initiatives, Kurt Fisher when he was alive, and a lot of people. Do you have a quick prospectus on what it would take to make action or to translate what you're doing into something that can be more tractable by educators?
In the context of the work I do on emotion, or the
especially that, because that's where that would be a big need.
Yeah, how we take so in academia, there's different levels, of things that are just theoretical,
right?
And then you have empirical work that you're trying to understand, for example, these switches between cortical and midbrain regions, models for fear and anxiety. How do you take that information then and apply that to help people have anxiety and disorders of fear, panic disorder, for example? Well, you get an understanding of that, but we don't specifically have drugs that can go into those brain regions.
Right.
Yeah. So you're providing knowledge, but it's sort of like a little bit disembodied. So the work that we do,
bridges.
yeah, exactly. And then and we do work with colleagues at UCLA and to ask these questions in anxiety disorders. This has been a bit different with our recent work here, which is looking at social media. And now we can completely see how we can take that information about what we learn about the brain and their behavior and their subjective and emotional responses to that, and begin to implement ways to reduce that type of anxiety. So we can then think about ways in which we can educate kids. For example, this is something we're doing: educate children on how to control their emotions, how to communicate with people online, because this is a new frontier for human nature.
Absolutely.
So that's one example of how we can apply the science directly into from theory, the science theory, and then into real world applications. It's not always the case in academia.
Yeah, that makes sense.
And then just thinking about it from the sort of educational perspective as well is, I think that with my daughter, who's of course here at LILA, what we've been interested in some respects is trying to educate, is expose her to as much as possible.
That makes sense.
As many different things. So when she's exposed to music, art, and so on, all of a sudden they begin to find their pathway to what they want to do. But without that, it's kind of a narrow road, to find out what they want. I had to find it out myself, and like most of us do as adults, but a lot of time kids kind of know quite early what they want to do if they've been exposed to all these different paths. Well, they may change, but still, I think that's an important element.
So we went from Sternberg's triarchic theory of intelligence, analytical, practical, creative, to the need to really nurture more creativity in schools. The importance of multiple available pathways and experiences to really stimulate all sorts of connections and opportunities.
And the key thing as well is, I think beyond all of that, you have the rocket fuel, which is motivation. And how do you push it? You can be as creative, you can have the highest IQ. There's a guy called Christopher Langdon, and he has one of the highest IQs in the world, 195 or something. And he dropped out of college. He got F's when he went to one of the colleges. Has come up with some crazy theories, and so he's great at test taking, but the application of that IQ to real world important questions is zero. There's another element. So there's the element of, he's clearly motivated, but then the direction in which you apply that intelligence is also important as well.
That comes back to another important point you were making, linked to your research, which is understanding anxiety, fear, and using that to self-regulate. And maybe to sort of know yourself better. That's all tied into things like motivation, I think.
It is. Well, metacognition is a key element. Metacognition is the ability to understand your own internal cognitive processes, understanding yourself in some respects. And the classic example of a breakdown of that is known as the Dunning-Kruger effect. People, as you guys,
the worse you are, the better you think you are. There's a lot of that I've noticed.
Definitely. And I think that's a classic example of lacking the ability to have insight into your own abilities. And the way they do that is they'll give them a test, and then they say, how well do you think you did? And then that discrepancy between actually how well they did and actually well they think they did is your measure of the Dunning-Kruger effect. And
a great metric.
Dean,
it's been a real privilege learning from you and engaging with you on life, your story, education, intelligence, and this fantastic research you're doing. So thank you for coming.
Thank you. Thanks for inviting me. Thanks.